Welcome to part 2 of counting methods. So today we'll start with permutations of objects when some group of items are identical. So in the previous video, part 1 of counting methods, we ended with permutations of n unique items. So this is the formula we use to calculate permutations when we have some group of items that are identical. So n there represents the total number of items that we have. So we are having subgroups of the identical items. So the n's at the bottom simply means that the number of items in the subgroup that has the identical objects. So without wasting any time, this is just a simple example. So it says how many different 5-letter words can be formed by letters in the word digit. So you can see that we have 5 letters there. That is our n. And then you can see that we have one subgroup, which is we have I as an identical item there. So the i's are identical, guys. So n1 will be 2 factorial because it is the number of items in the subgroups, right? So you'll simply say 5 factorial divided by 2 factorials because we have 2 letters that are identical or the same. So another example here says how many 11-letter words which start with the letter S and end with the letter I can be formed by varying the letters in the word Mississippi. So now there you have 2 conditions. You have conditions, and I told you in the previous video that every time you are given conditions, make sure that you start first with the condition and then you can take care of the rest. So we have 11 letters and they are saying how many 11-letter words we can form when they start with S and end with, what is that, I. So even though you have 4 S's there, when a word starts with an S, guys, it starts with an S. So whether you choose the S in the 3rd position or the 4th position, there is no difference. The word will still look the same. So that's why there's a 1 there to show you that there's only one way you can choose the first letter, right? So the same thing applies with an I. So even in the last position we will have 1 because of the same reason I gave you for the S. It means that we've chosen the first and the second letter. So of the 11 letters, we have 9 letters that are remaining and they did not say anything about them. There is no condition, so you can just do the permutation of the other letters. So we are left with 9 letters. So of the 9 letters that are remaining, because we took 1 S to start the word, we'll be left with 3 S's and then 3 I's. The other one is there, and then you can see that we also have 2 identical P's. So that's why in the middle we have 3rd solution there. So we'll be starting with combinations. In the previous video, part 1 of counting methods, I explained what combinations mean and which formula do we use in combination. So you know that the combination formula is the one that says n choose r. So without wasting any time repeating things that you already know or that I've already done, we'll just do an example to see how this works. So it says syndicate V has 5 members. So yeah, whatever 5 names you can come up with, it doesn't matter. So it says the syndicate has been asked to nominate 2 members to represent them at an upcoming conference. In how many ways can this be done? So we have 5 members and 2 of them have to be nominated in order to represent the group or the syndicate in an upcoming conference. So what I want to explain is that from the previous things we've been doing, you saw that in permutations they will tell you that you've got maybe this number of people and they have to fill certain positions. But in this case, you can see that the people are there and there's nothing or no positions to fill. They just want you to choose or to nominate. So that's how you know, or you get a sense that, oh, now this is a combination problem. So you are just going to say 5 choose 2, which is 10. So the difference, so I want to show you the difference between combinations and permutations using these two questions. So we have A, B, C, D, and E. So they say write down or find the combinations formed by taking 3 letters at a time. So guys, in combination, I told you that order doesn't matter, right? So you are just going to say 5 choose 3. So whether it's ABC or CAB, that's the same thing. We count that as 1. So when you are writing your combinations down, you know that ABC and CAB or BAC is the same thing. So you won't count them as 1, 2, 3. You'll just circle them and say they mean the same thing. But in permutation, the order matters. So ABC, CAB, they are different. We have 2 permutations there. But if it's a combination, we have 1 combination. Right? So that is the difference between combinations and permutations. So I hope you understand, and yeah. So I won't say much about combinations, but that's all. Let's look at some counting method questions. So now guys, in this video I'll be trying to complete your slides so that I can start making videos solving 2018's quizzes. And so in the question the question says, in how many ways can 3 girls and 6 boys be made to sit on a bench in such a way that A says in such a way that the girls and the boys are each to sit next to each other. So we want the boys to sit next to each other, the girls to sit next to each other. So this is how we do it. So here it's just a visual representation of that I'm going to use that I can try and explain this better. So we know that we have 3 girls and we have 6 boys, right? So they are saying that they have to sit next to each other. So the girls have to sit next to each other, the boys have to sit next to each other. So how can so we will say 3 factorial for sitting the 3 girls, and then we'll say 6 factorial for sitting the 2 boys. But remember, these 2 groups or 2 sets of boys and girls, they didn't mention a condition saying that this one this set must start, or they didn't tell you anything about which set has to sit first, right? So it can either be that the girls sit first, then the boys come after them, or the boys can be this side and the girls can be that side. So that's why we have this 2 factorial here, to show that either the boys or the girls can start or can sit first. Wabo. So B says no 2 girls sit next to each other. So the condition is that no 2 girls sit next to each other. So we know that we have 6 boys. They didn't say anything about the boys, so you can just sit the boys. So the 6 factorial is to sit the boys. So if you are a girl, you know that you can sit anyway, but you cannot sit next to each other. So you can choose to sit next to any boy or in between any boys. So if you have a crush in class, you know that you're gonna target that seat next to him, right? So you have 7 positions you can choose from. Either sit here, here, or so it's 1, 2, 3, 4, 5, 6, 7. So there are 7 positions can choose from. So from the 7 positions, we only need 3 positions for the 3 people, right? So we are going to say 7 choose 3 times 3 factorial, right? So the 3 factorial shows that we are sitting the different girls, and the 7 choose factorial means that, okay, we acknowledge that we have 7 positions, we are choosing only 3. Thank you. The following question says a Stockfell consists of a total of 16 people, 5 married couples and 6 people who are single. In how many ways can the 16 people be seated to sit in a row in such a way that a member from each couple sit next to each other? So if you came alone, you are going to sit alone. If you came with your husband or your wife, you'll sit with them, ne? That's what the condition means. So guys, we have 16 people here. They are people, 16 people, and then we have 5 couples. Mind you guys, this visual representation here doesn't mean this is the way they are going to sit. No, I'm just trying to make you visualize these things. Hold on. Okay, we have 16 people, and then from that we have 5 couples, ne? So now they are saying that we should make them sit in a way that members from each couple sit next to each other, right? So we know that we have 5 couples. So now if we know that the couples have to sit next to each other, so it means that we are going to sit how many sets is the 6 single people and the 5 couples, so 11, right? So we are going to say 11 factorial, right? So by 11 factorial we are seating those people, because we don't know, guys. This couple can sit here, then maybe we'll have some single people and then the other couple sit, so we don't know. So by 11 factorial we are just sitting them in. You can view it as a way that of saying that, okay, those people have 11 alternative ways they can sit in, but not forgetting that the others are going in twos, right? So now the couples can sit anywhere, and then even those ones can choose to sit anywhere. But when a couple chooses a spot, you know that they will be occupying 2 seats, right? So now the 2 factorial, now we are sitting the couple, because it's either the male can sit first then the female, or the other way around. So the to the power of 5 represents that there are 5 couples. It's like saying 2 factorial times 2 factorial times 2 factorial for all the couples, right? So guys, I'm going to try to be as quick as I can so that this video can be short, and you can see that some of the concepts are not thoroughly explained, but don't worry, I'll do a video where I'll be doing quizzes from 2018 and 2019 in order to explain the concept in depth, so that you can see how questions are set and how you can determine if a question falls under permutation or combination when you are not told that that is the case. It says none of the members who are single sit next to each other. So now the condition is talking about the single people, all the single ladies, all the single guys. So they are saying that those single people, they are not supposed to sit next to each other. So remember, we have 5 married couples, meaning that we have 10 people who are married, who are not single. So we are going to seat the 10 people who are not single by saying 10 factorial. So guys, in this question, we don't care if you are in an entanglement or not. If you're not married, we consider you as single in this case, right? So now the married people have sat down. So now the single people have a choice to choose in any position to sit in, but not next to each other. So if you are eyeing somebody's husband, it's your time to shoot your shot. Seat 10 people, obviously you are going to have 11 free positions. So we are going to say from the 11 free positions, choose 6, then multiply by 6 factorial. So we've chosen the positions times seat the 6 people now by 6 factorial. Okay, now we move from that. There's a theorem here I'm just going to read out. It says the total number of combinations that can be formed from n distinct items is 2 to the power of n. So guys, as you can see, I've been skipping some of the examples in your lecture slides, and I won't dwell too much into some of the examples because I want this video to be very short, because the last one was very long and some of you were not happy about that. So be sure to prove that theorem and prove all the other theorems that they said prove in your lecture slide. So now we are going to do an example under that theorem. So the question says, after breakfast, each guest at the B&B is allowed to take a tray with at least one of the following fruits: an orange, banana, peach, apple, mango, a pear, and a plum. In how many different possible ways may a guest fill her tray? So guys, the question said each guest is allowed to take at least one of the following fruit. That's that, in the last video I explained that. So at least means a minimum. So each guest can take a minimum of one. Yeah, at least one of the following fruits. So guys, so the thing now is that at least one is very broad, because at least one means a minimum of one. Yeah, you can take 5, the other one can take 6. Hey, and then those who love food, can take 10, 10, 10, 10. So you won't be able to lay out all the possible ways of at least one. So in a case that you have a situation like that, what you do now is that you are going to say, okay, they said at least one. So as I've said earlier, that at least one is a very broad case, because let's see, what's my favorite fruit? Okay, that doesn't matter. I can choose to take like 50, like I can also take for my family, but that's not the case. Even if you try to work out all the cases of at least one, like you won't finish now. What if the other one, hey, we are those greedy people who come with bags and then I'll take 10 of each, or even 100, or the whole packet. So you can't do that solution manually and get the answer. So in a case like that, what we do is that we are going to solve for the opposite of that case. So we know that they said that each guest can get at least one, so we know that the opposite of that case, it's the guest getting nothing, no fruit at all. So the answer for the case of the guest getting 0 fruit, getting no fruit at all, is 2 to the power of 0, which is 1. And then we know that the theorem that we just read said that the number of combinations that n different items can make is 2 to the power n. So we know that the total sample is 2 to the power n. So now our solution will be the total sample of the combination, the total combinations that can be made from that sample, or from that statement given, which is 2 to the power of 7, minus the case that was not mentioned, the opposite case. So we know that the answer will give us the answer that is suitable for the case that we are looking for, because we are minusing the opposing case from the sample, from the total sample space, so that we'll be left with what? We'll be left with the case we are actually looking for. So your answer is 127D. I hope you understand. So anyone who believes that they can get the answer using at least one, not using the opposite case, if you strongly believe in that, we can place a bet. I don't mind. So we are getting to sharing n distinct items amongst k distinct recipients. So this is ordered partitioning. So when we partition, this is what we are going to do. So the question was asking us that in how many ways can ball bearings A, B, C, and D be shared by Jacob and Helen in such a way that Jacob gets 1 ball bearing and Helen gets 3. So I'll show you this method of how I do most of the partitioning questions, and also this other method, which might be the one that you saw in class. I'm not sure which one they've shown you. So you have both you'll have both methods, and then you'll choose which one works better for you. So now we have Jacob, we have Paul, we have Jacob and Helen, and we have to share the balls between Jacob and Helen. And then they say Jacob gets 1 ball and Helen gets 3. So you know that your recipients are Jacob and Helen, and then the different things that are being shared is the balls. So this is an easy example. In the next video, when I'll be compiling quizzes, you'll see how sometimes it gets difficult to know what is your K and what is your N. So what you are going to do is that here you'll say Jacob 1, Helen 3. So when you are partitioning, you are going to use this formula that of the 4 factorial from the 4 balls and 1 factorial which comes here divided by 3 factorial that comes here, you will get your answer as 4. This one is another way you can do it. I'm sure you know how to use this because we've spoken about it a lot. So why this method there? So you'll see like in the next video that other questions are very long. They are so long. So when you used the method where you show how your sharings will occur depending on the conditions, then you'll be able to see which of them repeat, and you'll be able to just multiply, maybe say 4 times the repeating things. But you'll see that as I explain using different examples. There's another question here. They ask that what is the total number of ways in which n distinct items may be shared by k different recipients? So the answer there is, what is k to the n? Yeah. So the example that we were given, they said what is the total? A class has 30 students. Every student in the class is made to sit for a test in each of the 6 subjects that they do. After the script have been graded, the best student in the subject will get a prize. So in how many ways may the prize be awarded? So your K is the recipient and your N is the number of things that are being shared. So you are going to say 30 to the power of 6. So now I'm quickly going through the theorems and the concept. So I promise to upload another video that where I'll be dwelling more into those things and making examples, and right. So when you are sharing n identical things to k different recipients, this is the formula that we use. So a quick example on that is they said that 49 computers need to be distributed to 4 libraries, each in one in Soweto, in Katlehong, in Alexandra, and in Tembisa. In how many ways can the distribution be done if each of the libraries must get at least 10? So we know that so each school has to have 10, at least 10. So we are going to start by giving the schools 10, 10, 10, 10, 10. So that one, because we already know like how much we are sharing to each school, or how many, I don't know how to explain this, but you already know how many computers you are giving to the school, right? So you are going to say 1. So of the 9 computers that are remaining, you don't know how they are going to be shared, right? So we said 49 minus 40 because we've already gave the schools 10 10 10, which is 40. So you know that you have to share the remaining 9. So using the formula that I showed you in the last slide, we will say 9 plus 4. 4 is our k minus 1. Choose 9, and then the answer is going to be 220. So I hope you understand where the 1 comes from. You already know you already know that you'll be sharing 10 to each, so you're just giving them that 10. There's no need to share the 40. Do you understand?